Okay, this is a easy problem. This says write down the structure of stereoisomers formed when cis-2-butene is reacted with Br2. So I have cis-2-butene. So let me write something like this: CH3 hydrogen, and there is again carbon, hydrogen, CH3. So this is cis-2-butene. You can see 1, 2, 3, 4 carbon, double bond at position number 2. So this is 2-butene, and this is cis because both hydrogen is same side. So if this compound reacts with bromine, what will be the product you will have? So you have to write down the stereoisomers, cis-2-butene. So this is a cis. Now this problem we have already discussed in the class. You know what is the answer. So let me show you the mechanism how we will get the product. So you see the addition of bromine is anti, if you remember. So what will happen? So let me use the CC. So I have one hydrogen that is going inside, another CH3 that is coming outside. Same thing here on this carbon, one hydrogen that is going inside and one CH3 that is coming outside. So this is the formula we have. Now if I add bromine, I will add one bromine from bottom and another bromine I am going to add from top because the addition is anti. So one bromine I am going to add from top, another bromine I am going to add from bottom. So let us say if I do this, what I will have? Now this bromine will be added from bottom, and this hydrogen that is slightly lift up. So you will have hydrogen here, and here you will have CH3 that will lift up in the same plane. So you will have CH3. Are you getting? Now if you see here, bromine will come from the top. So this is the bromine, and this CH3 that will go slightly down. So that will slightly lift down. So you will have CH3 something like this. And hydrogen that is the behind the plane that will go slightly below. So we will have hydrogen. I think all of you are able to see this one. So hydrogen will go slightly below the plane. So it will look something like this. Now if you make the Newman projection of this compound, so you will have, so let us say call this carbon is a carbon number 1, this carbon is a carbon number 2. If you look from this side, you can make the Newman projection. So it will look something like this. This carbon, that is the Br, is the down. So this is the Br, and there is a hydrogen that is something like this, and there is a CH3 that is looking something like this. If you see the back carbon, the bromine is here. So here you have bromine, and CH3 that is downside. So here you have a CH3, and here you have a hydrogen. So this is the compound you will get after writing the Newman projection formula. If you wish, you can also write down the feature projection formula of the same compound. So this is the compound you have. Only thing in feature projection formula, two bonds should come towards you. If you are looking from the top, so let us say I can rotate this bond so that this CH3 and hydrogen will go up, or I can do here itself. So if I rotate this, either I can rotate here, or even if I wish I can rotate here. It is easy to see here. So let us say if I rotate the back carbon. So if I rotate the back carbon, this is the back carbon. So let us say this goes here. So by 60 degree, if I rotate the back carbon by 60 degree, are you getting? So this I am rotating back carbon. So if I rotate the back carbon by 60 degree, what I will have? So the front carbon will look as it is. So you have the front carbon, hydrogen is here, CH3 is here, and then Br is here. Now back carbon, this bromine will look here, that is the closed position, and this CH3 will look here. So here you have CH3. Are you getting? And now this hydrogen will come here, so you have hydrogen here. Are you getting or not? So you will have this configuration. Now if you want, you can also draw the feature projection formula of the same compound. If you look from the top, so if you are looking from the top, what you will see, so now I am making the feature projection formula. If I am looking from the top, I will see 1 bromine and CH3 on this carbon. So 1 bromine and CH3. And on this carbon I will see hydrogen and CH3. Are you getting? On this carbon, hydrogen is below. On this carbon, bromine is below. So this is the feature projection formula I will get. Are you getting? So this is the feature projection formula I will have. If you wish, you can do interchanges also, because 2 interchanges does not make any change. So if you want, you can take hydrogen downside. So what you do is, do 1 interchange here. That is, bromine goes here, hydrogen comes here, and then do again 1 interchange from here to here. So we will have hydrogen goes here, bromine goes here, and CH3 goes here. Are you getting or not? So first interchange you will have bromine here and hydrogen here. Now next interchange, bromine will go here and CH3 will come here. So this is the second interchange you will have. So finally you can write the same thing. I am writing because in that case I will write hydrogen in that is the vertical line, hydrogen, and then this will remain as it is, CH3 Br, and now this CH3 will go here and this Br will go here. Are you getting? So CH3 and Br. So this is the formula you have in the terms of feature projection formula. Now this is given if I have attacked on this carbon from the bottom, on this carbon from the top. Now you can do the same thing. If attack happened in a reverse order, this means on this carbon, so let me write again, because some of you are new. We have already discussed in the class. Those who are able to understand this one, do fast yourself, because we have done in the classes. CH3 you have, and here you have hydrogen, and here you have CH3. So this means on this carbon this is coming from bottom, top, and this carbon coming from bromine is coming from bottom. So here it is coming from bottom. And now I am not doing anything. You have to analyze the same thing. You have to do the same kind of procedure. You have to add this one, make the Newman projection formula, rotate, draw the feature projection formula. If you follow all the steps, it will come the second compound that will have feature projection formula. In that case, this Br and this Br is anti. Now you will have something different. So you will have another isomer. So if you do this one, so let me write here. So you will have 2CH3, HH is here. Now you will get the mirror image of the same compound. So CH3Br. So you will have CH3 Br, and then this side you will have BrCH3. So mirror image. So if you have this compound as A, you will get the compound B, that will be the mirror image of compound A. So this is compound B. So this is the mirror image of A. Are you getting? So in this case, you can simply write on cis addition. So what we have, I have compound is cis, my addition is trans, and the product I am going to get is racemic mixture. This we have already derived in the classes. So I will get racemic mixture. Now if I have trans, so if I have trans and addition is also trans, in that case the product will be meso. So this means if somebody asks on trans 2-butene addition of bromine, what will be the product? So I have trans 2-butene and addition of bromine, what will be the product? Of course in this case product will be meso, because addition is trans and compound is also trans, so product will be meso. So let us go fast on the next question. We have taken already a lot of time in this question.